Objectives for today's lesson: illustrates deciles, solve problems involving deciles, and interpret deciles. Deciles are the 9 values of a variable which divides its distribution into 10 equal parts. D sub 1 is the first decile under which 10% of the total population lies. D sub 2 as the second decile under which 20% of the total population lies. D sub 3 as the third decile under which 30% of the total population lies. D sub 4 is the fourth decile under which 40% of the population lies. The fifth decile under which 50% of the total population lies. Sixth decile under which 60% of the total population lies. Seventh decile under which 70% of the total population lies. Eighth decile under which 80% of the total population lies. And the ninth decile under which 90% of the total population lies. To calculate deciles for ungrouped data, first we have to order all observation according to the magnitude of values, and then we will be using the formula d sub m equals m times the quantity n plus 1 over 10 th value. M here is the mth decile, while n is the number of data. Let us deal with the first example. Calculate the third and the seventh deciles of the following ordered pairs. So we need to arrange first the data in ascending order. That is our first step. And then we will be using the formula d sub m equals m times the quantity of n plus 1 over 10 th value. And then we count the total number of data, and that will become our n, which is equal to 9. Now we are ready to solve for the third decile. And that will give us d sub 3 equals 3 times the quantity of 9 plus 1 over 10 th value. And then we simplify. We need to copy first the 3 and then simplify what is inside the parenthesis. 9 plus 1 over 10, and that is 10 over 10, which is equal to 1. So we just need to multiply 3 times 1 and it will give us 3. And we are going to locate the third value in the given data set. So the third value is 18. And that will be our d sub 3, which is 18. Now let's have the d sub 7 or the seventh decile. So 7 times the quantity of 9 plus 1 over 10. So we copy first the 7 and then simplify what is inside the parenthesis, and that is 1. So 7 times 1 is 7. So we will be locating the seventh value in the given data set. So the seventh value is 27. And that will be our d sub 7, which is equal to 27. Now let's have the second example. Calculate the fourth and the ninth deciles of the following ordered pairs. So we need to arrange first the data in ascending order, and then count the number of data, and that will serve as our n, which is 12. And then since we are looking for the fourth decile, it means that we will be using d sub 4 equals 4 times the quantity of 12 plus 1 over 10. Then we copy first 4 and simplify what is inside the parenthesis, which is 12 plus 1 over 10. And that will give us 13 over 10, or simply 1.3. And then we multiply 4 times 1.3. It will give us 5.2. So since we have here a decimal point, or 5.2, we will be locating the fifth and the sixth value in the given data set, and that is 52 and 55. So the next step is we are going to subtract the sixth and the fifth value. So that will give us 55 minus 52, and the difference is 3. And then the difference, we need to multiply it to the decimal point of the d sub 4. So the decimal point is 0.2. So we need to multiply the result by 0.2. And it will give us 0.6. Now for the next step, we are going to add the result to the smallest value or the smaller value between the two, which is 52 plus 0.6, and it will be give us 52.6. So it means that the fourth decile is 52.6. Now let us calculate the ninth decile. So we will be using d sub 9 equals 9 times the quantity of 12 plus 1 over 10. So we copy first 9 and simplify what is inside the parentheses, and that will give us 1.3. And then we multiply, which is 11.7. So in here, we need to locate the 11th and the 12th position. So that is 69 and 73. The next step is we need to subtract the 12th and the 11th value, which is 73 minus 69, and it will give us 4. Now, the obtained difference, we need to multiply it by the decimal part obtained in the position of d sub 9, and that is 0.7. So we need to multiply 4 by 0.7, so it will give us 2.8. And then the next step is we are going to add the result or the 2.8 to the 11th value, and that will give us 69 plus 2.8 equals 71.8. So it means that the ninth decile or the d sub 9 is equal to 71.8. Now let us try to find out the deciles for group data. So we will be using the formula d sub k equals lb plus the quantity of k times n over 10 minus the cf sub b all over f sub dk times I. So in the formula, LB means the lower boundary of the D sub k class, while N is the total frequency. CF sub B is the cumulative frequency of the class before the D sub k class, while F sub dk is the frequency of the D sub k class. I is the size of the class interval, while K is the nth decile. So N here represents 1 to 9. Okay, now let's begin. Calculate the third and the seventh decile of the mathematics test scores of 50 students. So in here, remember the lesson we had on quartiles. In obtaining the lower boundaries, we need to subtract 0.5 from the lower limit of each intervals. So it will give us the following results. For the less than cumulative frequency, we need to locate the lowest class interval, and then we copy the, the frequency, and then we're going to add 6 plus 12 is 18, 18 plus 9 is 27, 27 plus 11 is 38, 38 plus 8 is 46, and 46 plus 4 is 50. So, what do we mean in obtaining this less than cumulative frequency? It means that on this interval, we could find here the first and the sixth score, while on 26 to 30, we can find here the 7th to 18th score. On this class interval, we can find here the 19th to 27th score, while here we can find here the 28 to 38 score. In the interval 41 to 45, we can find here the 39th to 46 score, and the 47 to 50th score, we can find it on the interval 46 to 50. Now we are ready to solve for the third decile. So we need to locate first the D sub 3 class interval, and we will be using the 3 times n over 10. We substitute the value of n into 50, and it will give us 3 times 50 over 10, or 150 over 10, which is equal to 15. So we're going to locate which interval does 15th value belongs. And it belongs to the class interval 26 to 30. And with that, we're going to mark this 26 to 30 as our D sub 3 class interval. Now we're ready to identify the lower boundary, which is 25.5, and is 50 CF sub B, or the cumulative frequency below the D sub 3 class, is 6. The frequency of the D sub 3 is 12. And I is the class size, in which we have 5 scores within 26 to 30. And so the class size is 5. So we will be substituting the values to the formula. So we have here 25.5 plus the quantity of 15 minus 6 over 12 times 5. So we will be working on the parenthesis first. So 15 minus 6 divided by 12, and then multiply the result by 5, and then add the result by 25.5, and it will give us 29.25. So it means that 30% of the students have a score less than or equal to 29.25. Now for the 7th decile, we need to use the d sub 7 equals 7 times n over 10. So we just substitute the value of n into 50. We have 7 times 50 over 10, and it will give us 350 over 10, which is 35. It means that we are going to locate in which interval does 35th value or score belongs. And it belongs to the class interval 36 to 40. So the next step is we are going to mark this class interval as our D sub 7 class interval. Now, identifying the lower boundary, which is 35.5, and is 50. The CF sub B, or the cumulative frequency lower than the D sub 7 class, is 27. Frequency of the D sub 7 is 11. And then the class size is 5, since we have 5 scores within 36 to 40. And then applying the formula, we just need to substitute all the values. So we have 35.5 plus the quantity of 35 minus 27 over 11 times 5. So we have to work on the parentheses first, 35 minus 27, and then divide by 11, and then multiply by 5, and then add 35.5, and it will give us 39.14. It means that the 70% of the students have a score less than or equal to 39.14. Now try doing this on your own. Until our next session, thank you and enjoy learning.